In this lesson, we're going to look at how linear inequalities and word problems interact, or how linear inequalities apply to word problems. We're just going to investigate one word problem and see how it applies. This question says, Johnson Yang has a part-time job at Menchie's that pays him $15 an hour. He also sews awesome jogging pants and sells each pair for a profit of $12 each. The shop that he rents for sewing jogging pants charges $100 per week. Johnson wants net earnings of at least $500 per week. So to kind of give you an idea, what we want to do is find out all of the combinations of how many hours he could work at Menchie's and how many amazing jogging pants he could sew in order to make at least $500 a week. So one example of a solution is, let's say that he worked for 30 hours and also made 30 sets of jogging pants. Okay, what that would do is give us 30 hours of work would be $450. 30 jogging pants, because they're $12 each, would be $360. But then we know that he has to rent the store for $100, so that would be minus $100. His net earnings for that combination, 30 hours of work and 30 sets of jogging pants, would be a total of, looks like $710, which is at least $500 a week. So we want to investigate what are all the possible combinations that he could work and put this into some sort of graph to represent all those combinations. So first question here says, write an inequality that represents the number of hours that Johnson can work and the number of jogging pants he can sell for net earnings of at least $500. So before we do that, what I want to do is represent the variables. So I'm going to let x equal the number of hours, and I'm going to let y equal the number of jogging pants. As far as the inequality goes, what we know is that the number of hours times 15, so 15 times the number of hours, plus 12 times the number of jogging pants, minus $100, because that's a fixed cost. He has to rent a shop for sewing jogging pants. Has to be greater than or equal to 500. So this is the inequality that represents this word problem. His revenue, his net earnings, have to be greater than or equal to $500. Now what we can do is look at part B, which says what are the restrictions on the variables. That means basically, can the combination, when we get the solution region, just be any numbers, or is there any restrictions? As far as our restrictions go in this particular case, we can't work negative numbers of hours, and we also can't sew a negative number of jogging pants. So you could write it a number of ways. I'm just going to write it like this, no negatives. Or you could write the restrictions like this, x has to be bigger than or equal to 0, and y has to be bigger than or equal to 0. It's the same thing. Let's go ahead and graph the inequality. We looked at doing that in the previous lesson. The easiest way to do that is to graph the boundary line, and the boundary line is the line 15x plus 12y minus 100 equals 500. So if we put this into slope-intercept form, or isolate y, what we're going to get is subtracting 15x and adding 100 will get us 12y is equal to negative 15x plus 600, and then when we divide by 12, we're going to get that y is equal to negative 5/4 x, and 60 divided by 12 is 50, so plus 50. Now we know what we might want to do is go up by, we know that we have to have at least 50 on the y-axis because that's our y-intercept. So in order to decide what to go up by, here's our x, or our number of hours, our y, and our number of jogging pants. It may be valuable to go up by 5s. If that's not enough room, then we can change our scale. But that's one important factor to consider as we're graphing these inequalities, is what scale to choose on the axes. So I'm going to go up by the same scale on both axes once you've decided. All right. So to graph this boundary line, it has an intercept of 50 and a slope of negative 5/4. So if we go down 5 and over 4 from there, we're going to see that we have this boundary line. And that boundary line, because it's or equal to a revenue of $500, is going to be solid. So those combinations represent all the boundary of where he's making more than net earnings of 500 and where he's making less. As far as the combinations go, you could do a test point if you'd like to. I mean, you could test 0, 0. and ask yourself, would a combination of 0 hours and 0 jogging pants give you net earnings of greater than $500 per week? The answer to that's no, which means essentially you could show that work that it's the opposite side of this boundary line, which makes sense. That's going to represent all the possible combinations of jogging pants and numbers of hours of work that he could make and work in order to have net earnings of at least $500. So this represents all of them. And as you can see, the coordinate that we talked about at the beginning, 30 and 30, does exist within the solution region. That point is right here. So yeah, that point does exist in the solution region. As far as list, and part D says list 2 combinations of hours and jogging pants in the solution. Well, you can see we have one there, so I'm just going to use that one. 30 hours and 30 JPs or jogging pants. Another possible combination, and there's lots of them, could be, heck, this purple one right here. So that would be 25 hours and 50 jogging pants. That would also be part of the solution.